Time series data. Time series data is data that has been measured repeatedly over time. It could be measured per hour or per day, per week, per year, and you are measuring a particular variable at intervals in time. Time, if you're graphing time series data, time will always go on the x-axis, that is your independent variable, and you connect your points with lines. There will only ever be one data point per each year for a data set. We could have two different data sets, the population in town A and town B, and then you would have two lines, but you'll just get a single line for a single data set. And you can find a trend using this time series data. You might have a fairly linear trend, a straight line, a curving trend. It's obviously a pattern but isn't a straight line, or you might have no obvious trend. Now I suggest not copying this example and just view it if you need to so that you know how to graph time series data. So here we've got the approximate population of a rural town from 1990 through to 2005. So you need to put your time, this one is in years, on the x-axis. Your y-axis does not need to start from 0. This wouldn't make sense. Our lowest value is 700. Our highest value is 1300. So a reasonable gradation might be going up in 50s, and we'll go from below 700 up to 1300 or a bit above. So if you go from 600 to 1400 in 50s, then that should be fine. Leave enough space above for a title and on the side and bottom for your labels. Y-axis, if we start at 650, even gradations, of course, it's easier with grid paper, but I don't have grid paper here. And as always, I managed to not go quite as high as I would like. Put your gradations in on a line. They must go on a grid line or on a line of your paper. So this is population. You label that. Now, when you have not gone from 0 on your y-axis, you must put either a little zigzag, which I've just illustrated there, or more easily, two lines. The zigzag would go there, or the two lines would go there, to show that this is not another 50. This is not 0 to 650, and this is not 650 down to 600. You're saying I took a break between 0 and 650. Then we evenly space our years. You don't need to go a year out on these, so that first one there will be 1990. What do I need? 2003, 4, 5, I think. So, doing your best to get even little gradations there. Sorry, I should have been more consistent with that. I did want to make sure we knew this was 1990 and then 2000. So you can see that we have set up a graph that will take all those years and that full range of population. We label that year, and then it's a cross for each piece of data, and I would suggest that you do graphs in pencil, especially when you're marking the points. So 1990 we had a population of 1300, doing your best to place these accurately. 91, 1250. Again, this is easier with grid paper. 92 is also 1250. So you're just, sorry, I'll stop moving that. You're just marking a point at each of these coordinates. 94 is 1000. Just make sure you stay caught up on which one you're doing. You can always mark them off as you do them. So I'm up to 98. And we're up to 2001. Okay, so it looks like a scatter plot, but the most important thing then with a time series graph is these are connected. You know that between 1990 and 1991 it went from 1300 to 1250. So we indicate that with a line joining our points year by year. So you join them in order of the time. So I'm joining 94 to 95 to 96. So you may well get a jagged look like this, but this is in order of what happened to this population over time. Do not take it down to the axes at these ends. It did not go down to 0 before and after this. That is all the data we have, that is all we present. And we give it a title, and it pretty much comes from the description. And that is a graph of time series data.